first stage we uses TL072 IC1A dual low noise JFET. This is a non-inverting pre-amplifier stage. The leftmost capacitor C1 10 microfarad blocks the bias voltage from the input. The two 10K resistors form a voltage divider giving us 4.5 volts. The op-amp works at single supply mode. The resistor R2, R3 and capacitor C2, C3 form the bandpass filter. The pass band gain is 23 with the formula 1 plus 22 220K divided by 10K. The 10 microfarad capacitor C4 couples the output from the first stage to the next stage, which is a negative feedback loop amplifier. C4 passes the signal while blocking DC. From this measurement, we can see that when the frequency increases, the gain also increases to the maximum 21.89. We can also see frequencies above 500 will cause the gain to decrease. Gain 21.89 is equivalent to 26.80 decibel. So based on the frequency response curve, the minus 3 dB line will be at 26 minus 3, 23 dB. So the low frequency will be at 20 Hz and the high frequency will be at 1.5 kHz. Therefore, the bandwidth will be 1.5 kHz minus 20 Hz, giving us 1.48 kHz. Since the single supply mode will cause the negative side of the sine wave to be cut, the voltage divider will shift the entire waveform upwards to prevent any cut. I've set up the stage 1 to get the sine wave. I've connected my channel 1 to TP1 and channel 2 to TP2. I've set the VPP to 200 mV and frequency at 200 Hz. Now we can see that we get output as 4.60 volts and frequency of 200 Hz. When I change the frequency to 1 kHz, my output is 3 volts. At this stage, the signal from TP2 is fed into an inverting amplifier built around the TL072 IC1B. Resistor R4 sets the input resistance and limits the current going into the inverting input of the op-amp. The op-amp's non-inverting input is biased to half the supply of the voltage using a voltage divider formed by R9 and R10. This acts as a level shifter, centering the AC signal around mid-supply to prevent output clipping. The gain of this amplifier stage is determined with P1 acting as a trimmer in the negative feedback path. This negative feedback stabilizes the amplifier's gain, reduces distortion. The gain is given by P1 divided by R4, meaning the amplifier inverts the signal by 180 degrees, so the output at TP3 is 180 degrees out of phase. I've set up the stage to get a sine wave. I've connected my channel 1 to TP1 and channel 2 to TP2. And my frequency is at 1 kHz, but my sine wave is not clear. So I use the trimmer to adjust and get a clear sine wave. Now I get a sine wave with 5.12 volts at 1 kilohertz, and when I change it to 200 hertz I still get 5 volts. In this stage, the signal from TP3 is fed into the bandpass filter built around TL072 IC2A. The input signal is AC coupled through C5 to block DC. Resistor R11 and R12 bias the non-inverting input to make supply acting as a voltage divider, preventing output clipping on a single supply. This stage is a second order active low pass filter. This stage uses resistor R7 and R8 together with capacitor C6 to form a frequency selective network. This network passes only a certain band of frequencies while rejecting signals outside the band. Capacitor C7 in the feedback path further shapes the filter's frequency response. This bandpass filter ensures that only targeted frequency ranges moves forward to the next stage, improving signal quality and rejecting unwanted noise. Finally, capacitor C8 couples the filtered AC signal to TP4. As the lowest frequency can pass through a low-pass filter is 0 Hz, the bandwidth of a low-pass filter coincides with its cutoff frequency. The bandwidth of low-pass filter coincides with its cutoff frequency given by this equation. I have set up the stage and connected channel 1 to TP3 and channel 2 to TP4. I have set VPP as 5 volts and frequency as 200 Hz. I'll get a sine wave with 4.7 volts as output. And when I change the frequency to 1 kHz, I get 2.32 volts as output. In the final stage, the input from TP4 is sent to the LM386 audio power amplifier. Before reaching the amplifier's input at pin 3, the signal passes through a potentiometer P2 where pin E has full amplitude and pin S and A has zero amplitude. This stage drives current to the speaker. In C15, filter out high frequency above 40 kHz. And C13 blocks DC. Resistor R17 together with capacitor C15 forms a Zobel network to stabilize the amplifier and prevent high frequency. For this stage, we do the same thing as previous stages. Connect channel 1 to input and channel 2 to output TP5. We can get output of around 7.2 volts at 200 Hz. And when I change the frequency to 1 kHz, I get output as 3 volts. You can adjust the trimmer P2 to control the output at TP5. Shine with a tinge without being saturated.